A window function performs a calculation across a set of table rows that are somehow related to the current row. This is similar to using calculations with aggregate functions, but unlike regular aggregate functions, you don't have to group rows of data into a single output row. In simple, plain English, this means that the rows get to retain their separate identities, so you get to keep all of them, rather than having to lose some due to aggregate functions and group by. Hey, my name is Mo Chen, and I work as a data and analytics analyst within the financial services industry. In today's video, we'll perform some advanced SQL queries using window functions with PostgreSQL. First, I'll walk you through how you can easily import a CSV file into a PostgreSQL database table. Then, we'll move on to writing advanced SQL queries using the over, partition by, row number, rank and dense rank, and lead and lag clauses. If you stick around till the end, you'll even learn how to write an advanced query that'll pick out the top 3 booking prices within a specific neighborhood, which is within a specific neighborhood group within our New York Airbnb dataset. All of the links to the resources are in the description below. Make sure to check them out if you want to follow along. You'll need the pgadmin tool, which is going to be your PostgreSQL tool, and if you already have this installed, great. But if you don't worry about it, because I have a link to my full SQL database course in the description that includes PostgreSQL database installation for both macOS and Windows. So, without further ado, let's get started. Okay, so first things first, I'll show you how you can easily import the CSV file into your PostgreSQL database table. There are numerous ways to do this, but what I like to do is create a database first, then create a table within this database, and then use the psql command line tool to copy the values from the CSV file into our database table. So let's just move on to Kaggle quickly. You see at the top here, there's a link to the Kaggle file in the description below. So we'll be working with the New York City Airbnb open data. And if I just move my big head from here, then you can see that you can just hit the download button and then you can download the data for yourself. So let's go back into the pgadmin tool. Let me move my image back up here. And then let's go to the top left, onto databases, right click, and then hit create. So let's call the database New York Airbnb, and then leave everything as is. And then you can hit save to create your database. So once this is done, you can see that within the New York Airbnb database, we have a bunch of options. You can double click into schemas, and then under schemas, go into tables. And then you can see that we have nothing under tables, which makes sense because we haven't actually created a table. So let's move on to creating this table. Go to the top left and open up a new query tool. So once you've done that, all you have to do is just a simple create table query, which I will copy and paste in right here. So you can see that you can use the create table keywords, define the table name, and then you pass in all of your column names right here. You have to define the data type, so we'll have integers, we'll have varchars, we'll also have some decimals, and then we'll also have a date column. And then we'll define the primary key on the booking ID column right here. So you can either go to the top to hit this play button, or you can hit F5 to run your code. So let's do that. And you can see here that the query was returned successfully. So now, if I go into my New York Airbnb database, right-click and hit refresh, and then go to the bottom under tables, you can see bookings table appears here now. So how do we know that we've actually created this other than checking here? You can also check in the query tool. So we can select everything from bookings. I'll hit F5. And then you can see on the bottom that all of the column names are right here. So we have successfully created our bookings table. So now that we've created our table, let's use the psql command line tool to copy and paste the values from the CSV file into our table. And thanks to Latitude for sponsoring this video. Think of Latitude as a data workspace for startups. With Latitude, you can connect to multiple sources in the data exploration process. More than 100 data sources are supported. Connect your database, data warehouse, and other sources. With Latitude, teams can unlock the power of data through the built-in AI SQL assistant, manually writing SQL queries, or visual programming on an infinite canvas. Latitude uses OpenAI's GPT models to suggest code and entire SQL functions in real time. Moreover, you can explore and visualize data simultaneously in one place. Pick the charts or tables and add them directly to your canvas, and share them with team members when you're ready. So, if you're interested, try out Latitude now for free using the link in the description below. So let me just open up my psql command line tool right here. And if you don't have any of these installed on your computer, don't worry about it, because I do have a link to my full SQL database course in the description. So you can just use that, as it includes a full PostgreSQL database installation for both macOS and Windows. So once you're in your psql command line tool, for localhost, all you have to do is hit enter, because we'll use the default one. For the database, obviously, just switch to the newly created New York Airbnb database, and then port as it is, hit enter, username as it is, hit enter, and then the password will just be whatever you chose for your password. So now you can see that we have successfully connected to our New York Airbnb database through the psql command line tool. The next up, we'll be using the copy from command to copy all the values from the CSV file into our table. And this \copy right here is actually a psql command. So you just pass in \copy, you define the table name, so which table you want to copy the values into. And then the from clause here, basically all you have to do is just find the local place within your local directory where you downloaded this file here, the AB New York City 2019 CSV file. For the delimiter, obviously it's a CSV file, so it'll be commas. Then we define the file as CSV with headers, and we want UTF-8 encoding. So once you do that, I can just hit enter, and then psql will just do the job for us. So we can see the message here, copy 48,895. This just means that we've successfully copied 48,895 rows into our table. So let's go back into our table here, and let me just rerun this bit of code here. And let me just do that. You can see now that our table has been populated with the values from the CSV file. So let's quickly have a look at our data set right here. We have quite a couple columns, and the ones we'll be mostly interested will be booking ID. We'll also use the listing name, host name, neighborhood group, neighborhood, and then moving on, we'll also use the price column, and then we'll also use the last review column. And I think that's it. I believe these are the columns that we'll be working with within the next couple exercises. Thinking of Airbnb and traveling, actually, what are the most memorable holiday destinations that you guys have been to? Or what are some destinations that you guys would love to go to, some destinations that are on your bucket list? Let me know in the comments below. Okay, so let's move on to window functions, and the most basic ones will be just with the over clause. So this is what we'll cover first. We'll get the average price of all things with over. So the average price of all bookings with over. So all we'll be using here is average price, and then we pass in the over clause, and that's it. So let me just run this code here, and you can just run a portion of the code by just highlighting the code and then either hitting F5 or running the code with the play button at the top. And then now, if you see here within the average column, we have $152.72, which is the average price of all bookings. Now, moving on, we can of course get the average, the minimum, and the maximum price with the over clause as well. So let me just do that. The only difference is this time we say min price over and then max price over right here. And then let me just run this code again. And now you see we have the average, we have the minimum, and then we have the maximum price. Now, of course, you can see that the minimum price here is 0. So that may not be correct, but I guess for the purposes of this tutorial, because it's on window functions rather than data interrogation, I'm just gonna leave it as it is now and move on. So the next thing we'll do is we'll calculate the difference from the average price with over. So this time, again, I'm selecting booking ID, the listing name, the neighborhood group, the price, and then I will round the average price to 2 decimal places because it just looks nicer. And then I will take the difference of the price and the average price, and then again, I will round this to 2 decimal places because it just looks nicer, and call this column as difference from average. So let me just run this bit of code here. And there we go. Now you have the price, the average price, and then you have the price minus the average price. So you can see the difference between the two. Next up, let's calculate the percent of average price with the over clause. So this time we'll calculate the booking price as a percentage of the average price. So again, selecting booking ID, listing name, neighborhood group, the price, and then this time our calculation will be price over the average price times 100 because we want the percentage. Again, we'll round it to 2 decimal places, and I will call this column this time percent of average. So let me just select this query here. Let me run all of this. And there you go. You can see now that the booking price here, so row number 1, 149 is 97.56% of the 152.72 average price. And how about we just do one more query? How about we get the percent difference from the average price? So let me just paste this query in, and then this time we'll get the percent difference from the average price. So again, price divided by the average price, and then we take away 1 and times that with 100 to calculate the absolute percentage difference from the average price. So let me just run this code again. And here we go. Now you have the total percentage difference between the price and the average price. Okay, so now that we use the most basic over clauses, let's introduce the partition by clause. Partitioning by is kind of like grouping by, except it happens within the over clause. So first of all, we will partition by the neighborhood group. And again, I'm selecting the booking ID, the listing name, the neighborhood group. And this time, I'll also select the specific neighborhood within this neighborhood group. I'll select the price. And then I say I want the average price. And then again, we're using the over clause right here. But this time, we're partitioning by the neighborhood groups. And then I'll call this column as average price by neighborhood group. So we will find the average price within each neighborhood group. So let me run this code right here. And you can see that the Bronx values will be exactly the same in the average price by neighborhood column. So the average price within the neighborhood group Bronx is $87.49. But let me just scroll further down and say, for example, you see Manhattan here. So the average price within Manhattan is a lot more expensive. And this is $196.87 is the average booking price within Manhattan. Okay, so just to get a feeling for the unique neighborhood groups within the bookings table, let me just run this line of code here. And let me show you. We have 5 different neighborhood groups. So we have Queens, Brooklyn, Staten Island, Manhattan, and Bronx. And then we can, of course, also see the different specific neighborhoods within these neighborhood groups. So let me just run this code here. And you can see that we have quite a bit more specific neighborhoods within the neighborhood groups. All right, so next up, let's partition by the neighborhood group and the specific neighborhood within each neighborhood group. So let's get the average price within each neighborhood group and then within each specific neighborhood within those neighborhood groups. So this line of code will do it here. So the only difference is this time, instead of partitioning just by the neighborhood group, we will partition by the neighborhood group first, and then we will partition by the neighborhood. And I'll call this column as average price by group and neighborhood. So let me just run this bit of code right here. Let's run the code and see what we get. So if you look at the last column now, you see that within Bronx, within Allerton, the average price is 87.59 compared to the average price just in Bronx, which is 87.49. But let me just scroll further down. So let's pick another neighborhood, say, for example, Chelsea. Within Manhattan, the average price is $249.74. And then the average price for Manhattan, the neighborhood group, is only $196.87. So next up, let's do some calculations and we can calculate some differences between the booking price, the average booking price within a specific neighborhood group, and then within a specific neighborhood within a specific neighborhood group. So let's do that next. And you can see that the last 2 calculations here, these will be the deltas. So the first one will calculate the difference between the booking price and the average price within the neighborhood group. Now the second calculation here will calculate the difference between the price and the average price within the specific neighborhood within the specific neighborhood group. So let's calculate that. Let's run the code. And now you see that the last column here is going to be the difference between the booking price and the average booking price within this specific neighborhood within a specific neighborhood group. And the second to last column will be the difference between the booking price and the average price within a specific neighborhood group. Okay, next up, we will start ranking things using row number. So first of all, we'll get the overall price rank within the entire dataset using row number and then over, and then we'll order by the price descending. So DESC is just the keywords for descending, and I'll call this column as the overall price rank. So let me just run this code here, and let's see what we get. So if you look at the last column now, we have overall price rank. And you can see that the first three values are all 10,000, but the first value is actually of rank 1, the second one of rank 2, and the third one of rank 3. So row number, when the values are equal, it'll just move on to the next value, and it'll give it a distinct, unique next rank. Now next up, let's get the neighborhood price rank. So the only difference now will be this row of code here. So you can see that I'm using row number again, but this time, within the over clause, I am partitioning by the neighborhood group, and then I'll order by the price descending, and I'll call this as neighborhood group price rank. So let me just run this code now. And now if you look at the last column, we can see the price rank within each specific neighborhood group. So let me pick Brooklyn, for example, row 2 here. You can see that $10,000 is the highest booking price. But then if I look for the next line of Brooklyn right here in row 8, you can see that 8,000 now is the second highest in this neighborhood group. And then let me just move on to the next Brooklyn value. So right here, row 11, you can see that $7,500 is the third highest booking price within this specific neighborhood group. All right, so moving on, let's do something a little bit more fun, introducing a case statement. So we will try and retrieve the top 3 booking prices within each of the neighborhood groups. So now the new bit of code we'll add is this case statement here. So I'm saying when the row number, and then I'm using the over clause partitioning by the neighborhood group again, ordering by the price descending. So when this is equal to or less than 3, then give me a yes flag, otherwise give me a no flag, and I will rename this column as top 3 flag. So let's see what we get now. Let me just run the code, and let's look at the top 3 flag column. So you can see that as long as these values here will say 1, 2, or 3, I will get a yes. And then otherwise, I'll just get a no. So if you look at row 1, it's a yes. Row 2, again, it's a yes. Row 3, it's a yes. But row 4, again, still a yes. But if you look at row 5 now, because the neighborhood group price rank is 4 here, so 4 is clearly greater than 3, so my top 3 flag will say no. And then the next line, so row 6, again, I can see that the neighborhood group price rank is equal to 2, so the top 3 flag will be a yes. But then if I look onto row number 7, you can see that the neighborhood group price rank is 5, so the top 3 flag will be no. Now we can use other clauses to rank our data as well. We can use rank or dense rank, and I'll walk you through the differences between row number, rank, and dense rank. So next up, let's use rank first. So the only thing that's changing is right here. So I'm saying rank over order by the price descending, and this will be the overall price rank with rank. And then I have another line of code here, which will be the overall, the neighborhood group price rank with rank. So the only difference is we change the row number to rank. And let's run this code right here, and let's see what we get. So if you look down the columns here, we have the overall price rank, and then next to it, we have the overall price rank with rank. So you can see that when the values are equal, so if you look at the first 3 rows of data here, what rank does is that it actually just makes them equal. So the value 10,000 here, and the value 10,000 here, and the value 10,000 here, the corresponding rank values are all 1, 1, and 1. But if you look at the overall price rank column right here, when we used row number, you can see that even though these values here, 10,000, 10,000, and 10,000 are equal, the row number just moves on to the next rank, or rather the next row number. So it'll be 1, 2, and 3 versus 1, 1, and 1. And then the next value, if you're using rank, will be 4 now, because obviously this is the 4th value in the list. So again, if we look at the neighborhood group price rank and the neighborhood group price rank with rank, you'll notice the exact same things. So next up, let's use dense rank. And again, this time, the only difference now is that I included 1 row number, 1 rank, and 1 dense rank clause. So let's see what the differences will be this time. Let me run this code here. And then now we have the overall price rank using the row number clause. We have the overall price rank with rank using rank. And then we also have the overall price rank with dense rank. So now you see that the difference between dense rank right here and rank is that dense rank, after saying that all the three 10,000 values are equal, when it moves on to the next value, it'll be 2 rather than 4. And then these values are equal, so you see we have three $9,999 values, and then when it moves on to the next value, so the $8,500 value, it'll say it's 3, compared to the rank bit where it says 111,444 and then 7. And finally, let's move on to lag and lead. So what lag will do is it'll bring in the previous value. So let's go through this one first. We'll use the lag keyword. We'll lag the price. Again, we're using the over clause because it's a window function. And this time we are partitioning by the host name and then order by the last review, which is a date column. So let me run this bit of code right here and let's see what we get. Let's look at the last column right here, and we have a bunch of null values, which is fine because when you're bringing in the previous of a nothing, as in the previous value doesn't exist, then you'll get a null. But say, for example, let's look at the host name email hidden by Airbnb, which is probably not a great host name, but whatever. Let's look at this one. So if we look at row 6, row 7, and row 8 first. So in row 6, you can see that the price is 200. The last review date is 2014, August 30th. And then we have a null value for the lag value because we don't have a previous review date. But now, if you look at row 7, we can see that the price is 261. The date is 2016, August 23rd. And this time, the lag price is 200. Now this 200 is this 200 right here. So essentially, we just brought in the price of the previous last review date. And then if you look at row 8, you can see that the price is 139. The last review date is 2018, November 17th. And then you can see that this time, the lag price is 261 because we just brought in the price of the previous last review date. All right, now next up, let's lag by 2 periods. So rather than just lagging, obviously, by 1 period, we'll lag by 2 periods. And the only difference now is that we'll define the lag periods by 2 right here. And let me just run the code again, and let's see what we get. So now let's look at the same rows 6, 7, and 8. And then if you look at row 6 and row 7 now, for the lag row, we have no values. So for row 6, previously, we also had no values. But now for row 7, we also have no values because we have no price going back to previous last review dates. But if you look at row 8 now, you can see that this price is 200, which is corresponding to this 200 here. So if we just count back 2 periods, 1 and 2, this is that 200 right here. And this is how we lagged by 2 periods. Okay, so now that we've covered lag, let's cover lead as well, which will be exactly the opposite. So we'll get the next value or the next whatever values we specify. So first of all, let's lead by 1 period. And you just need to change the lag keyword to lead right here. Otherwise, everything remains the same. Let me just run this code right now. And now we can look at, again, the same rows of data. So we can look at row 6, 7, and 8. And then you can see that this 261 is the next 261 value coming from here. And then in row 7, this $139 is actually coming from the price of the next last review date. And that's it. And then, of course, let's cover lead by 2 periods. So again, the only thing you'll have to do is specify the periods. So you'll pass in 2 right here. And then when you run the code, this time you'll get the value 2 periods from the current value. So let's look at the rows again. If we look at row 6 right here, this $139 here is actually coming from 2 periods after. So right here, this $139. Okay, so last but not least, let's move on to something a little bit more complicated. I did promise you in the beginning of the video that we'll do something quite fun and complicated. So this is it. We'll be using this query that we wrote from before. We put this into a subquery, and then we only get the booking prices that are actually within the top 3 within each neighborhood group. So the query, the subquery, is exactly the same as before. We have this case statement right here, with which we created a top 3 flag column. So I will alias this query right here with an A, and then I will select everything from this query right here, but I will introduce a where clause saying that the top 3 flag must be a yes. So let me just run this code here. And now you see that I only picked out the ones that are actually in the top 3. So we only have the booking prices for the listings that are actually in the top 3 within each neighborhood group. And that's it. That's the end of the video. If you liked this one, make sure to check out some of my other videos right here. Thank you so much for watching, and I'll see you in the next one.